Now we'll see one more functionality of your data link layer protocol, that is framing. So far I did not tell you that the higher layer is network layer. From now onwards we simply say that the higher layer is network layer. So you don't know what is network layer, leave it. I'm going to teach you network layer. At that time we clearly understand what is network layer. At this moment network layer is one of the higher layer. So from network layer you are going to get the packets, and that packets you are going to give to physical layer, so that physical layer is going to send the messages, right? Now when you take the packets from network layer, generally usually the size of packets are very long. Then data link layer's responsibility is successfully sending the packets, isn't it, like postman? So that's why now you have a responsibility to send them successfully. For that, if you maintain very long messages, that means even data link layer also takes directly packets. Usually let's say assume that packet size is 10,000 bits. Now if you directly send it, then what can happen is, we know that line has sometimes corruptions, right? That means, so your bits might get corrupted. Then again we have to send all the 10,000 bits, because data link layer is going to take that responsibility to send the packet successfully. If that is the case, then why to maintain very long packets, so that any error in any bit might cause you to send again lot of bits, correct? To avoid that, what we do is we simply divide that packet into multiple small chunks. They are called frames. So now we are going to do framing. That concept is called framing. How data link layer is going to do framing? Usually what does it mean? Logically it is dividing your packet into multiple parts, correct? But how to do that, so that your receiver also understands that this is the frame number 1, this is the frame number 2. Because see the binary pattern, if your packet is 01010101 something 1001, then it looks like, framing is easy. Simply say that up to here it is frame number 1, then here to here frame number 2. In logical level it is easy, but in physical level, really when you implement it, how you split the message into parts, we will see. So if you don't say simply that, if you say simply in your mind but don't explain to receiver, then receiver thinks that everything is one frame. That's why every frame should have two things. One is start of the frame, second one end of the frame. Then how you convey that this is the start of the frame, this is the end of the frame. That is the beginning point of the story called framing. We will see how framing can be done. There are so many ways. So we will see one by one and pros and cons of every method. Okay. Now we'll see various procedures. First of all, we start with character counting, which is not so popular. It has its own limitations, we will see. First of all, we understand what is character counting. Let's say this is the message which you are going to get from network layer, and you want to divide them into frames so that you can send at a time one frame, right? That is what your concept. So for that, what you do is, you simply add, simply add character count for every frame. That means first of all you decide what should be your frame. Here you can have variable length frames also. That means 1, 2, 3, 4. So you can divide your frames into two parts. Example here, 4 characters one frame, 5 characters another frame. This will be done by your data link layer at sender. Okay. Now since you are using 4 characters in one first frame, then first fill 4. That means you are forming a new message now. 4 comma 2 comma 3 comma 4 comma 5. That means what? This 4 indicates that there are 4 characters after 4 that are going to form one frame. Then again after that you see 1, 2, 3, 4, 5 is going to be the new frame, right? Then the number of characters in that one is 5. Then write again 1, 2, 3, 4, 5. In that way manipulation will be done and you will be forming the frames. It looks like only one single message, but logically if you see, this is one frame according to this data link layer, and this is another frame. Now receiver is going to receive in the same way. How this frame 1, frame 2 will be received by your receiver, we will see. So you will be sending now, let's say continuously you are sending, you have a chance now, and through this cable we are sending, this is your receiver. So you are sending lot of frames. Then how your receiver is going to separate that frames? If you send one frame at a time, there is no question of separating, because sender knows that he is sending only one frame, receiver is also knowing only one frame. But what if you send multiple frames? Let's send this entire sequence. Still your receiver is going to divide the frames, we will see. you will be sending like this. First of all 4, correct? Whenever 4 reaches, so receiver and sender will have this common agreement. Sender should follow this model and receiver also will follow the same model. What receiver will do is, he will take the first character and receiver thinks that 4 means, oh, so the next 4 characters are going to be one first frame. Then he will imagine like this. That means he will take 2 comma 3 comma 4 comma 5 into one set of frame. That means he will imagine like 2 3 4 5 as one frame. Then he will keep on counting the number of characters which he got. So 1 2 3 4, right? After 4 characters, now if 5th character comes, then again this 5 is going to come again. Whenever he gets 5, so sender again receiver thinks that 5 means next frame length is 5. Then he will ignore that 5 and next he will be forming a new frame with exactly 5 characters. Then you can imagine like this. There may be a counter. Initially it is 0, then 1 comes, then he will write here and he will increment the counter. 2 comes, then he will increment the counter. 3 comes, he will take and he will increment the counter in that way. So he will form the new frame. See, finally he is able to separate into frames. So finally sender and receiver are having the same imagination about their frames. In that way, framing will happen. Sender and receiver happily they communicate through these frames. That is one way. But the problem with this framing is, especially through character counting, is, see, what if this first bit itself is corrupted? Yes, we know that line has errors. So because of the errors, then what if this character gets corrupted? That means one of the bit in it, and because of that 4 becomes 7. Then what happens? So receiver is going to receive in this way, because its first bit is 7. So he will wait for 7 characters first. So he is going to form 2 3 4 5 5 1 2 as one frame. Then after that, so see, 3 plus 4 7. Then he will come to this point. He will see 3 and he will think that 3 will be the next character count. That means next frame count. Then he will count 4, then 5, then he will wait for another character, but he won't get. Slowly he realized that there is a mistake. Sometimes he might not be able to realize also, but whatever may be the case, so if there is a corruption in the bits, then definitely you are going to get all the wrong things. That's why that is a problem with character counting. But you might argue like this, sir, we have error control protocols, right? That means we have CRC, everything. Then if really there is a corruption in the bits, then we can cross check using our CRC, right? Yes. So 99% of the time there will not be any problem, but very rarely if that kind of thing happens, that means let's say really your CRC is not able to detect the errors. In that case, definitely you mess up everything. That is a problem with character counting, of course. Otherwise we can use it, not a problem. Now we'll see byte stuffing algorithm. In byte stuffing algorithm, what happens is, let's say this is your message 01001010 0100, so on, very long message. We are going to divide it into frames. Okay, for that, see, it will be very difficult if I write binary patterns, correct? What I do is I group every 8 bits and I write the corresponding ASCII code. Okay, so though it is a binary bit, definitely binary pattern, but let's represent with some meaningful characters. So in ASCII, according to ASCII code, so every character will have one unique pattern, right, with 8 bits. Though we are sending binary patterns in the cable, but in the high level we think that we are sending the characters. Okay, let's imagine our data as some set of characters. So example, let's say your message is A B C D, but of course, so every character has a binary pattern, right? End of the day we are sending bits only, but in the high level, let's imagine that is A B C D. How we are going to convert them into frames, I am going to teach using byte stuffing algorithm. In byte stuffing, what we do is, like these characters, there will be one special character called flag. So we are going to use that flag character, which is which is of size 8 bits, to start the frame and end the frame. Example, you want to make this entire thing as one frame, then simply you add flag comma A comma B comma A. This will be done by your data link layer algorithm, which is byte stuffing algorithm. That means in which layer this will happen? Data link level. So in the network layer you get this binary pattern. That is nothing but this character sequence. That will be converted to flag ABA flag. So your data link layer is going to decide the frame size. If your data link layer decides that frame size, first frame size 24 bits, then it will write like this, flag ABA flag. That is the idea about byte stuffing. So we will see why we say this is byte stuffing. First of all, let me convert into frames. Second frame would be again flag B. Let's assume that this is the second frame BCD. Then flag BCD flag. Since sender and receiver agrees upon that, if you send it, what happens, you see at receiver side, assume that let's say there is no error. If there is no error, what is going to happen is, first of all, this flag will go, correct? Because your receiver knows that whenever there is a flag, that is just this flag is start of the frame, then this will be discarded, then remaining thing will be counted as frame, right? ABA. Suddenly one more flag comes, then that flag will be discarded by your receiver and it will finally form a frame, correct? That is what even sender is expecting. After that, this flag will come, then that will be discarded as the start of the sequence, then BCD will be taken, then when again end of the flag is seen, then this BCD will be formed as a frame. That is the way this exact framing will be understood by your receiver, correct? Finally, your sender is assuming this ABA as a frame and BCD as a frame, then your receiver also understanding in the same way. So this byte stuffing works, correct? But the problem we will see now, what if your data contains flag bits? We will see. So sometimes it happens, sir. When it happens, example, let's say your data is image, otherwise you are representing video through your data. Then what can happen is, image or video can contain any binary pattern, then flag kind of binary pattern also possible in your data, right? Then if that is the case, then how can you handle? Will it work like your old algorithm? Will try. So we will be converting your frames. Let's say this is your frame, this is your another frame, okay? Now frame 1, frame 2, that is what your data link layer protocol at sender side is thinking. That's why it is adding flag bit here and here in between data. What is the data? A comma P comma flag, correct, comma C. So remember it. Now this is only for our imagination. After that, again new frame will be formed like this. Add flag, then write the data, D flag. This will be done by data link layer protocols. Then E comma F. After that, end of the flag. When you send this one, so what happens at receiver side? Receiver receives flag first, then it thinks this is the start of the flag. Perfect. Then it will take A and it will think it as data, then B data, then flag. Because according to our notation, whenever you see flag, it should be end of the data, right? That's why. So flag will be discarded and A comma B will be made one frame. That is absolutely wrong. Why did you get mistake? The reason you did not consider this, you did not consider that data contains flags, then your old technique did not work. Then what to do? A small modification if you do, then our technique will work. That is nothing but stuffing extra symbol that is called end of the file, usually EOF. This is one special symbol in ASCII character set, any binary pattern, a special pattern. So we add again a special pattern EOF. I can say that before any flag, we will see that. Example here, we have data flag, right? This is flag in data, right? Not control flag, I can say. That means this is not start of the frame, not end of the frame. It is data flag. So if you have data flag, what we do is, while framing, first of all, we write control flag. That means start of the frame, then write A, B, and whenever you see flag, then write EOF, then flag. So slowly you understand what happens, why it works. Then see, then since frame is done, right, add flag in that way. What is the idea? For every frame, add flag at front and at end, right? So D flag E comma F, right? D, before that add flag. Then see, since data contains flag, add EOF, a special symbol, FLAG, then E comma F, then end of the flag. So when you add like this, then your algorithm should be modified. From now onwards, it's like this. Whenever you see flag, then that is start of the flag. Okay. Now after that again if you see flag, that is the end of the flag. That is quite normal. But apart from that, whenever you see EOF in the format, whenever you see EOF, then after that immediately whatever you see, that is not control character. That means that is not a delimiting thing. That means that is going to be data. Don't touch it. Understand? Let's follow that. Okay, flag. So now let me follow the algorithm. Flag, start of the symbol, correct? That means after that your frame is going to start. A, discard it. So frame has been started. B, data. Now when you see EOF, discard it. We know why we use EOF, discard it. Then after that don't touch the next one. That means don't process it. If it is flag, don't think that it is end of the flag, because it will be data. Blindly remember it is data and don't touch it. Then continue. Add flag because it's data. Then C, yes. Now again flag. Now this time there was no EOF, right? That means it is a end of the flag. Then we formed a frame. Next, start. Again flag. Start of the flag frame. Then D, data, right? Then EOF. Whenever you see EOF, discard it. Then next, skip it. Next symbol should be skipped. It's data. That means add flag. After that, EF. When you see this flag without EOF, that means that is the end of the frame. In that way, successfully we are able to separate into frames, correct? Sender is thinking that AB flag C is the data, D flag EF as the data, we are getting the same. So because of the help of EOF, remember. But last problem we have to solve, what if your data contains EOF? We have to discuss that, okay? Let's see that. If your data contains EOF like this, A, B, EOF and flag, then C comma D. Let's say you are converting A comma B as one frame. Okay. So EOF and flag another frame, C and D as another frame. That is what your target. For that, how your data link layer will write the symbols, flag first, then AB, flag, right? Start and end. Done. Then after that, this is a new frame, right? Flag, then EOF. But you know one thing, right? Whenever your data contains flag, we are going to add EOF to the data, right? EOF flag, right? Then end of the flag, because frame is done. In that way, we are going to do the framing. Then CD, flag, CD, flag. This is the way your data link layer at sender side will convert your frames, correct? Now we'll see what receiver will do. According to receiver's knowledge, very simple. First flag is start of the frame. Next flag is without EOF, end of the flag. But if you see EOF, then next data item is definitely data, right? Let's see that. First of all, your receiver sees flag, it discards it. It says that start of the flag. Then A, data, B, data, then it will see flag, end of the flag. Perfect. First frame has been successfully interpreted. Then again flag, start of the frame again. Perfect. It will be discarded. Then what happens? EOF. So whenever you see EOF, according to our algorithm, whatever we have seen so far, what it has to do? Skip the, whenever you see EOF, discard it. Next one is data item. Yes, take it. Now after that, this one flag. Now this flag will be treated as end of the flag, correct? Then it will be discarded and EOF will be treated as one frame. But that's wrong. Why this time, though it is data flag, why it is imagined as end of the flag? Simple. Already start of the flag has been started, correct? Now because of one more EOF, so what happened is when you added EOF between this flag, so this EOF is, because of this EOF, you are treating this as data, but it is actually control symbol, right? But because of this EOF, you are treating it as a data symbol, so that you are writing EOF and we are misunderstanding this flag as again data, control symbol, otherwise end of the frame, correct? So to avoid that, what we do is simple. From now onwards, 3 steps. Step number 1, for every frame we add one flag character in front of the frame and one flag at the end of the frame. Second thing, whenever you see flag in the data, then add EOF. Done. Third one, whenever you see EOF in the data, you add EOF for EOF and for flag. If you do that perfectly, we can do the things. We will see that. Example, let me take the same thing. Let me explain you. So AB, right? This is frame number 1 according to your imagination. This you want to say frame number 2. This you want to say frame number 3, right? Let's start. Flag, then A comma B, then flag. Perfect. Then next, EOF flag, right? Whenever you see EOF, we have to add one more EOF. That is called, byte stuffing. This EOF byte should be stuffed one more time. But let's begin with frame. Add start of the frame. Then since it is EOF, write one more EOF. Okay. Then since it is flag, data flag, then add one more flag. Because your data link layer protocol knows that this is everything is data, right? At that time there is no confusion. Some students think that, sir, this flag is data or control. Definitely data, because initially you have everything data, right? That's why this will be treated as flag. Since data contains flag, what we have to do? We have to add EOF. That's it. Then flag. Then end of the frame, correct? Then what to add? Flag. Then after that, new frame. Start with flag, write CD and end with flag. So this will be the sequence. Now how this protocol is going to perfectly understand this one? Start of the flag, correct? So start of the frame. Take it, discard this one. Now start the frame. A, then B, correct? Now again you saw flag, discard it, end of the flag. Yes, successfully I found the frame. Next, fresh. Start of the flag. That means what? This is going to be start of the frame. Perfect. Discard it. Now we are waiting for end of the frame. Remember it. Correct? Start. EOF. EOF is what? It's a control symbol. Whenever you see EOF, what we have to do? We have to discard it. And next thing, whenever there is a EOF in our pattern, the next symbol is data. Let's take it. Okay, fine. And still remember, what is the state we are? We are waiting for end of the end of the symbol. That means flag. But I am not getting flag, right? Then see, again EOF. Whenever I see EOF, how to think about it? Next symbol is not control. That means it's data. That's why it will be taken. Now see, after that, this one. This flag came without EOF. That means what? Definitely now it should be end of the frame. That's why this will be discarded. Now when you reach end of the frame, then again new frame starts, correct? Yes, correct. Flag, new frame symbol, then C, then D, then flag. This flag came without EOF means what? Then we have to discard it and we should say that it is the end of the frame. So finally I got all these three frames. Understand? Now let's summarize it. So whenever you see first EOF, that means what? Next symbol is definitely data. To have this kind of imagination, what you have to do is you have to append, otherwise you have to prepend every flag with EOF and every EOF with EOF. That is one thing. Second one, while interpreting, whenever you see EOF, then we should discard it and the next symbol, whatever it is, should be treated as data symbol. If you do that, automatically, properly your frames will be separated by your receiver. The way how your sender is understanding, in the same way we are understanding. Okay. Now we'll see bit stuffing algorithm. So it is different from byte stuffing algorithm. In byte stuffing algorithm, what we did, the binary pattern, whatever you got from network layer, then you represented or you somehow interpreted it as some group of characters, correct? That's why, you took 8 bits and you simply said it's a group, correct? But that grouping was meaningful on those days because at that time ASCII pattern, otherwise, characters were represented as ASCII pattern on those days. But nowadays we are representing our character set as Unicode. We know that. That means, so characters are represented with 16 bits. Then grouping the message as 8 bits is meaningless, correct? That is one reason. So byte stuffing is not so popular nowadays. Second thing, however, nowadays we have integer data, floating point data, and we have images and we have videos. So if you have these many data kind of data elements, like various elements, then So grouping it as a character data, otherwise integer data, everything is meaningless. So in bit stuffing algorithm, so we don't assume our data as a character or integer or anything. Then simply whatever the data it is, simply we keep it as it is. So that's why in bit stuffing algorithm, we treat this as a raw data and we are going to do bit stuffing. That means some bits we are going to stuff to say that this is the start of the data and this is the end of the data. That means, sorry, frame. So how to stuff the data is this binary pattern. So this is a special binary pattern 0, 6 ones and 0. This binary pattern we are going to stuff before the frame and end of the frame. Example, let's say the data link layer realized that up to this point that should be one frame and up to this one it should be frame. Okay. Then after realizing it is going to stuff this character, I mean this pattern. Let's see that 0, 1, 2, 3, 4, 5, 6, 0 followed by this your frame. Frame is 1, then 1, 0, 1, 1, 1, 1, 1, 1, 0, 1, end of the frame, right? Then again you stuff 0, 1, 2, 3, 4, 5, 6, 0 in that way. Okay, so we can complete the remaining thing also. But the only problem is, what if your data contains this pattern? Yes, it happens because you know your binary pattern can be anything. Then example you see 0, 1, 2, 3, 4, 5, 6. Yes, then your receiver might think this as end of the frame and again he will do the mistake, correct? That's why to avoid that what we have to do is, so in the data whenever you see this pattern, add 0 after 5 ones because we should not have 6 ones in the data pattern. So what I am going to do is I will tell you. Example, let's say your data pattern also contains like this 1, 2, 3, 4, 5, 6 ones. After that 7, 8, 0. When you have this pattern in your data, what you have to do is you simply after 5 count the number of ones 1, 2, 3, 4, 5. Then after that insert 0. Okay. So this is called bit stuffing actually. Then so again 1, 2, 3, there are only 3 ones, no problem. Then your data will become 0, 1, 2, 3, 4, 5, then 0, 1, 2, 3, 0. This is an example data, right? Now we are going to add this 0, 6 ones, 1, 2, 3, 4, 5, 6, 0. Then at end of the frame 0, 1, 2, 3, 4, 5, 6, 0. When you send this one, how your receiver is going to correctly receive it, I will tell you. First of all, it will see this pattern. Now the question, is it really the control frame? That means, is it really the start of the frame? Definitely start of the frame. Why? Your data never contains 6 ones, right? And this is the first time occurring, that's why it should be start of the frame, not end of the frame. Then after that, 0 should be data, 1 should be data, 1, 2. Now see, I should count number of ones. Whenever I see again 6 ones, definitely that is the end of the frame. Because data never contains that, let me count it 1, 2, 3, 4, 5. But remember one thing, because you added some extra stuff like this 0. When did you add it? Whenever you see continuous 5 ones you added, right? Remember it, receiver has to remove it. Okay. So what receiver is going to do is, so it thinks like this, data has started 0, 1, 2, 3, 4. It will keep track of number of ones. Whenever number of ones are 5, after that it sees 0, that 0 will be discarded. Then again 1, 2, 3, correct? Then again 0, then 0. Then whenever a new one comes, then it will start counting the number of ones 1, 2, 3, 4, 5, 6. So why you got 6 ones? Definitely it is the end of the frame. In that way easily it can detect the start of the frame and end of the frame. And one more thing, in the data if you contain more than 6 ones or more than 5 ones, sorry. So whenever you see more than 5 ones, immediately you add extra 0 so that we can ensure that data never contain this pattern. And while receiving also, whenever you see 5 ones, remember it, then after that if you see 0, definitely we can say that that is added by us. Sir, what if your data contains like this 0, 1, 2, 3, 4, 5, 0, 0, 1, sir. Example, this is my data. Then are you not unnecessarily removing this 0? No. Example, this is your data. What I am going to do is, see, I don't want to write this much lengthy pattern. Let's give some meaning to it, symbol for it. Let's say this symbol is nothing but control. Okay, CTRL. It's a control information, right? CTRL. That means this pattern. Fine. I'm doing bit stuffing. CTRL followed by 0 at sender side 1. Add it 1. Yes, 1 1. Since there are 5 ones, whenever there are 5 ones, what sender has to do? It has to add 0. Though there is one more 0, we should add it. Then 0 0 1 will be added. After that again same pattern, let's say CTRL will be added. Ready? Now receiver side. First of all, receiver will see this pattern. Definitely it should be control information. That means start of the frame. Yes, discarded. Then data starts 0, 1, 2, 3, 4, 5. Your receiver is counting the number of ones. Whenever it reaches 5, the number of ones, then immediately it thinks that already bit stuffing has been happened. Then that 0 will be discarded. Then next remaining data will be taken 0 0 1, right? Then again it will see 6 ones because of this control, then that will be discarded. So finally you get your original data, right? This is bit stuffing. Now the final one is unusual patterns. So in some of the data link layer protocols, so depends on your medium, so this unusual pattern can be used. What is that? I will tell you. I will see the last one, unused patterns. In some of the systems, so there will be some patterns which cannot be used. That means, so we are not going to use them. So that patterns we are going to use to start the frame and end the frame. That means that patterns are going to become start of the frame and end of the frame. Let's see that. Example, let's say this is your data link layer. This is your physical layer. So sometimes depends on the medium, depends on the protocols, your physical layer sometimes use some redundant encoding scheme. Example, let's say one of the simple example is, let's say you have data item 0, 1. To represent 0, let's say your physical layer is using signals called, let's say voltage signals high, high for 1 and low, low for 0. If that is the case, there are two other patterns possible. One is high low combination, second one low high combination, isn't it? Then so two symbols, otherwise two signals we are using for one symbol, right? I can say that two signals are used for one data signal, correct? In that case, so these two are unused, so we never use them for data. Example, you want to write 0 0, then what signal will be sent is LL followed by LL. Okay, so if that is the case, then we can use HL comma LH for start of the frame and end of the frame. Example, you see 0101 is your message or frame. So what we do is we write HL here, okay, and we can use HL, anything, otherwise LH, whatever it is. So HL means what? One of the signal. Then 0 is what? Low low. 1 is high high. This is the way your message is going to be sent. 0 1. Low low, high high, high low. So when these signals go through the cable, then slowly they will receive at the receiver. Then receiver will receive first HL, then he will understand that that is the start of the frame. After that LL, definitely data element, data element, data element, data element. Suddenly whenever he see unused pattern like this, then that will be end of the frame. In that way, so frames can be recognized with start of the frame and end of the frame as unused patterns. Understand? So this is the, but only thing is, so to use this protocol, definitely such system in that, especially that physical layer should have this kind of encoding scheme. If your physical layer doesn't have this kind of encoding scheme, which is redundant encoding scheme, then you can't implement this kind of things. Okay, so these are the various ideas to finally do the framing. Okay.